All right, continuing on from yesterday. Yesterday we worked with long division, some synthetic division a little bit, and also synthetic substitution. We went through evaluating a polynomial here and how we can do it by substituting in by synthetic substitution, putting our values in for x, and put our x value in a little half box, throwing our coefficients down. Then we went through a long division problem where you guys proved to me that 87 minus 84 was equal to 11. Appreciate it. We did it using polynomials. But now what we want to be able to do is we want to utilize this to be able to use synthetic division. Okay? Use synthetic division to be able to use our division of polynomials because there's a lot of room for mistakes here. Okay, we went through a couple long division problems with it. A couple long division problems. If we take a look at this problem right here. We're going to take a look at this problem right here and how we can utilize the idea of long division to be able to, thank you. Sharon, Ms. Williams. How we can utilize long division to be able to help us, because when dealing with when you're dealing with long division, we have a lot of room for little mistakes there. We can use synthetic division to also do our division. Okay, and it's very similar to the idea of synthetic substitution. We are dividing by x minus 2. Okay, here we're dividing by x minus 4. If we take a look what's happening here, what our next coefficient is dependent upon up here is our coefficient down here. When I had a value of x here, and I divide that in here, my coefficient to this term, my first term is going to be 3. My next term, my value down here, my next term gave me a value of 11 here. My next term over here, I have 15 down here. I have a value of 15 up here. So my coefficients were always going to cancel off from left to right. What we want to be able to use is utilize this idea to be able to determine a quotient when dealing with synthetic division. Let's throw the minus 4 in. Let's go back up here. We'll redo this one here. Let's put the minus 2 in our little box. And let's run it through synthetic division and see what goes on here. Or synthetic substitution. If we put negative 3 in there, and we want to run that negative 3 through synthetic substitution. Well, if I drop my first quotient down, that gives me a value of 3. Okay, where our solution is going to appear is down here. My first coefficient here in my solution was my first coefficient, my leading coefficient of my polynomial. Because I have 1, I'm dividing 1 into 3, my quotient was going to be a value of 3 there. How we came up with our next value here. Okay, we had a value of 5, which is this 5 here. We multiplied 3 times 2 to give us negative 6. So if we multiplied 3 times this negative 2, we got a negative 6. But what we had to remember to do is we needed to remember to subtract. So we had to change this sign to make it positive 6, which gave me a value of 5 plus 6, which is 11. This is my 11 here, this is my 11 here, that's also my 11 up here. So this is being traced along here. My next term's coefficient is dependent on the second multiplication. Well, when I multiplied 11 times x, I got 11x squared. That went away. We knew that was going to happen. But then we multiplied the 11 times the negative 2 to give me negative 22. But we had to remember to change our sign again. So that came down to a plus, which gives us a value of 15. Which is my 15 that's right here, which is my 15 that's right here. When I multiplied 15 times the x, I got to the 15x, I subtracted down, and it goes away. When we multiply by negative 2 again, I get a value of negative 30, but we had to remember to change our sign again to give us a value of 39. This here is our remainder. If I take a look at my coefficients up here in my solution, I have 15, 11, and 3. Now what we have to do is we have to remember what to do with, we have to attach our exponent with a variable then. Well, what happens here is if I'm dividing x into 3x cubed, it's going to give me an x squared. If I go x into the x squared, it's going to give me the x. It gives me my x into the 7x, I get just a constant there. So what happens here when I divide by that, my x minus 2, my degree decreases by 1. So we have an x squared plus 11x plus 15 plus our remainder over x minus 2. The problem we run into here is that we have to remember to change our sign each and every time. Because if I don't remember to change my sign, I'm gonna have mistakes here. 87 minus 84 gives me 11. Okay? So, what can we do to make this a little bit easier on ourselves? They might remember what we do? Your fond memories of algebra 2, synthetic division. Well, every time we have to subtract, which means I have to change my sign here. Well, rather than multiplying by negative 2, negative 2, negative 2, and then having to change the sign, what could we multiply by? 2. So if I would just change this to a value of positive 2, now 3 times 2 is 6, I can add down. 11 times 2 is 22, then I can add down. And 15 times 2 is 30, then I can add down. So what I have to look at here is I have to look at this x minus 2. This is the opposite sign. And what this will eventually run into is, if you think about it, x minus 2 is equal to 0. And what we did up there with the valuation of the polynomial, we just subbed in the value of x that we have up here. Well, if I solve this, we solve this for x is equal to 2. That's the value that I sub in. That's the value that's going to go in my little half box here. So if I come down here to the bottom, I have a value of negative 4. I'm dividing by x minus 4. I have a 5x to the fourth, a 3x cubed, a negative 7x. Oh, I don't have an x squared term in there. So what do you think we should do if I don't have a squared term in there? Yeah, put a 0. We do have a square term there, but it's 0x squared. So if we think of this as plus 0x squared, I need to make sure I hold my place value, 0, negative 7, and a value of 4. Now what's the little value, what's the value that's going to go in the half box? No, what's the value going to be in the half box?
Could you use positive 4?
Positive 4. So we're going to put a plus 4 in there. Leave a space in there, run it through the synthetic substitution or synthetic division. And come up with a polynomial. Okay, your solution should be a polynomial, so write out a solution, make sure you get the remainder in a polynomial form. Which means you need to get your squares, your x squareds, x cubes, whatever it is. Here, we drop our 5 down, Angelique, what do we have here then? We diagonal multiply, 20, then what?
23,
Then what?
92, 92, 368, 361, 1,444, 1,448.
Okay, good with those values? Now putting it into a form, we decrease our degree by 1 because I'm taking x and going into x to the 4th. So if I'm dividing x into x to the 4th, that's going to give me an x cubed. If I have 5x to the 4th divided by x, well, the x's, they go to Texas, so I have an x cubed in there, plus 23x squared, let's see, plus 92x, plus 361, plus, and then I have my remainder I can put over x minus 4. What if I want to evaluate my polynomial for? What's the value of my polynomial for? Okay, going back up top. Okay, evaluating a polynomial for. What's our polynomial, what's the value of our polynomial for? I'm just waiting to see how many light bulbs pop on here. Kristen, what is it?
1,444.
How'd you get it so quickly?
It's already up there.
That's exactly correct. Where did the value of the polynomial come from? I said I was waiting for his light bulbs to start popping on there. Well, if I take a look at what we did up top, the value of this polynomial, 394, appears right here. We've already done the problem. So dividing by x minus 4, dividing by x minus 4 is the same as evaluating the polynomial at 4. It is the exact same thing. But when I evaluate the polynomial at 4, I'm just looking at the value at the very end, which is our remainder. Here's our remainder. That's the value of our polynomial. Double fold, twofold. Is 5 a factor of 45? Is 5 a factor of 45? Preston, is 5 a value or a factor of 45?
Yeah.
It is, okay. How do you know?
Because 5 goes in 45 by
Okay, so what's another factor?
45, 15.
But if 5 is a factor of 45, what's the other factor?
-5?
Don't overthink here. How do you know 5, what?
Oh, 9.
9, there we go. How'd you get 9?
5, 45 divided by 5.
45 divided by 5, we get a value of 9. 9's another factor of it. Is 3 a factor of 1,242? As I hear the magical clicky-clacking of the calculators, oh, how we forget our divisibility rules. Anybody remember it? Divisibility rule for 3 or 9?
If you add all the digits up and it's a greater amount of digits.
Okay. If you add them all up and that number is divisible by 3 or 9, then 3 or 9 will go into it. So if I add 1 plus 2 plus 4 plus 2, that gives me 3, 7, 8, 9. So yes, it is. Now what you may want to do is you may have to use your calculator to find your other one. What's your other factor, Brooke? 414. So you took the 1242 divided by 3, it came down to 414. Is 9 a factor of 4318? Is 9 a factor of 4318? Isaac, is it? How do you know? Okay? It's one way, divisibility rule. Anybody use your calculator to find that out? Vivi, did you use your calculator?
Yeah.
How'd you know it's not a factor?
I did 4,318 divided by 9.
Alright, and then what happened?
It was decimals.
Yeah, you came down to decimals. You came down to a number plus a bunch of decimals. So that tells me I don't have a factor there. Tells us we don't have a factor. Well, what does that mean? What does that mean if it's a factor or not a factor? We have 4318 divided by 9. You came down to numbers plus and some decimals over here. Okay, what's that mean when I deal with my division? Well, what that means is if x is a factor of y, then y divided by x, then when y is divided by x, the remainder is 0. It's called a remainder theorem. Something is a factor if you divide it out and your remainder comes down to 0. That's the key idea. My remainder is 0. If my remainder is not 0, then it's not going to be a factor. Why? We just showed it up here. Okay? 5 is a factor of 45. The other one's 9. Why? Because 45 divided by 5 is 9. Let's see. 1242 divided by 3. Other factor is 414. Why do I know it's a factor? Well, because my remainder was 0. Down here, we didn't come down to remainder 0, so it's not a factor. Or we can use our divisibility rules. So utilizing this idea, is x plus 2 a factor of x cubed plus 3x squared minus 4x minus 12? Is it a factor? Well, by the remainder theorem says is a factor if I divide one into the other and my remainder is 0. So what we have to do, well, unfortunately I can't collect that through the calculator. My calculator ain't advanced enough where I could type in a polynomial and divide it by a binomial and see what my division is, what my solution is. Rats. But we just learned on the other side techniques of division. So if I utilize my techniques of division and use synthetic division, I have my coefficients 1, 3, -4, and -12. What's going to go in the little half box here? That was going to go in the little half box. -2 because I have to change my sign. So I have a -2. So I run through synthetic division. Is it a factor? And if so, what's the other factor? Now when we run this through, we drop our 1 down, then what? When-
Times negative 2.
Keep going.
Oh, and then, it would be 1. And then negative 2, negative 6. 12, and 0.
0, so is it a factor?
Yeah.
Yes. Your remainder is equal to 0, so yes, it is a factor. Yes, it is a factor. So what's the other factor? Well, how do I know my other factor up here? Well, let's see. 1242 divided by 3 is 414. 45 divided by 5 is a value of 9. What's our other factor down here, Marissa?
1 and negative 6.
Well, this is a polynomial here. How do I convert this into a polynomial? What do we do over here? How do we convert it into a solution?
X squared plus x minus 6.
Oh, tartar sauce. X squared plus x minus 6. So here's my two factors. So these are my two factors. If I would multiply these two things together, I would get my original polynomial. Just like if I would multiply 5 times 9, I came down to my original value of 45. Well, this is a factor. What's the other factor is this. If I would multiply these two together, I would get x cubed plus 3x squared minus 4x minus 12. Is x minus 3 a factor of the other one? The polynomial? If so, what's the other factor? Jordan, did we get a factor? Let's see, negative 12, negative 36, 0. Winner, winner, chicken dinner. Yes, we do. So we have x plus x minus 3 is a factor. What's the other one, Jordan?
Which one did you? X squared minus x minus 12.
Now, since we take both of these down into this, we can find additional factors because I think we can handle x squared plus x minus 6. Can we factor this down to two other factors? Can we factor the x squared minus x minus 4 into two more factors? Once again, when we get into a trinomial, those are things that are factorable then. Those are things that we can handle. So we can use synthetic division to break it down into things that we can handle a little bit easier. Angelique, the first one factors what?
X plus 3 and x minus 2.
this be sort of like a prime factorization. If we had the value of 12, we can break into 3 times 4. Then we can break this down into 3 times 2 times 2. It's like a prime factorization, what we're doing up there. Our second one, what's our other 2 factors of the second one down here, Riley?
X minus 4, x plus 3.
Once again, it's like breaking down into a prime factorization. Okay, the factor theorem, or the remainder theorem, allows us to see, do we have factors or not? When something can easily divide it, or evenly divide in, well, we say it's evenly divided in, well, that means the remainder is a value of 0. We have no decimals there. Because what creates the decimals, if I had dividing into 13. Well, if I divide 3 into 13, it goes in 4 times, I get a value of 12. I have a remainder of 1, and we can write this remainder of 1 as 1/3. Well, the 1/3 is a fraction. When we have a fraction, that's going to create a decimal. And how do we get that fraction there at the end is when we do have a remainder. If our remainder is 0, I get 0 over 3. I have a remainder of 0, that gives me no decimals. But if I have 4 and 1/3, that gives me 4.333 and so on. It's not a factor at that point. So that's all the combinations of things that we have talked about and utilized throughout your math careers with respect to divisions and ideas of factors. Okay, for your homework, you have the completion of that worksheet I gave you yesterday. You were able to do the first few yesterday. Whatever you didn't get accomplished, you can complete. Solutions, I think, will still be there. I'll just tag the rest of these notes to the Google assignment. Questions you have? Okie dokie, as